Hello everyone. Welcome to this session on position estimation with IMU. In this session, we will discuss about the various components and algorithms that are involved in inertial navigation and position estimation from multiple sensors. We will clear up the process of utilization of IMU data into MATLAB and Simulink and their involvement for data collection, pre-processing, and design of deep neural networks, and how these design and train deep neural networks can be integrated into Simulink environment for real-time estimation or real-time application. So let's go to Simulink. In the Simulink, so let's explore what options do we have in for deep learning in Simulink. Let's go to Simulink library and you will find uh, deep deep learning toolbox. When you open this one in deep neural networks, you will find different uh, networks. What do we have? The first one we have here is image classifier. If you're working on an image classification problem, you can make use of this network. But for our application for today, we will be this is the block what we will be using from the Simulink library, that is stateful predict. If you want to learn more about this, or if you want to uh, have documentation on this one, just right click and go to help and you will find the documentation for this block. So in inputs, let's see what do we have. So in input it's taking a numeric array as an input and also is providing an output as a numeric array. We need to prepare our data so that in a numeric array form before feeding a train network into this block. So let's go back to our Simulink, and when you open this block, it it need a train network as a MATLAB file. So we need to create a train network so that we can feed here or give an input here. So let's go to MATLAB and train our network. We'll make use of MATLAB for training our network. So let me just open our MATLAB. So yes, this is okay. We are using a live editor in MATLAB. To train our network, we need to have a data set and we need to do some pre-processing for that. So for that, we need to bring the data into the MATLAB so that we can pre-process and train our network. There are different ways how we can import the data into the MATLAB or bring your IMU data into the MATLAB. If you have a recorded data as an Excel file or a CSV file, you can import directly into the MATLAB and do the pre-processing. Or if you are using an hardware where you want to stream your IMU data directly from the sensor or from the hardware into the MATLAB. For that, you need some support packages. You can directly install it from the add-ons. So, for example, let's open the uh, add-on Explorer, and you need to install few support packages. So if you're working on a microcontroller or if you have a specific hardware, so let's say if you're working on an STM series microcontroller, or if you have a Raspberry Pi, you can just open and install the uh, support packages from here, and this gonna if after installation you can directly connect with your hardware from the MATLAB environment. So once we have, or the third option is you can make use of the synthetic or the sensor models which are available in MATLAB and Simulink to generate your synthetic data. So these sensor models will generate the sensor data into the MATLAB and Simulink. And once you have your data, you can import the data and you can do some pre-processing. So your data has to be pre-processed maybe for removing, or you need to clean your uh, the traditional approach, they make use of a calm filter for this particular application. So initially you need to choose your filter for your application, and for example, the most popular filter what is used for this application is a Kalman filter. You can make use of a filter, then tune your filter and estimate for the position. But for our case, for today's session, we will be we will choose a deep neural network, and we will train or we will tune our network for the right options, for the right solver, and we will train our network for our input data so that it can estimate the position for an unknown or for a random data. So let's start with our process to create the data or create the training and testing data set. When it comes to the workflow for deep learning, this is a very general workflow for deep learning. That is, in step one, you need to access the data or import the data into the MATLAB and Simulink. And after that, you need to pre-process your data, clean your data, and normalize your data.